just call it A2 review. So on my webpage, you can go, or on my YouTube channel, you can go to the live streams and you can see the account. But all right, let's just start. So my YouTube channel, you can get from my website. There's a link straight to my YouTube channel. You can just subscribe, and then you'll be able to see when I go live, and you'll be able to see my live streams. If you can't find them, just shoot me a message, and I'll share it with you or show you how to do that. All right. So this first one, they're asking you to factor, probably. Is that what the instructions were?
Yeah, that was factoring.
Okay. So for factoring, one of the things, I mean, we can talk for literally 2 weeks about factoring, but I'm just going to cut right to the chase. For one of the things you have to learn is special factoring rules. And this is one of those that fits into that. If you have a squared minus b squared, that's going to equal, try this again. If you have a squared minus b squared, that's going to equal a plus b times a minus b. It's one of those special product or special factor rules. Okay. Yeah. So can you see that that's what I have here? Can you see that I have a 5x squared and then I have a 7 squared?
Yes, I do see that.
Can you see that? So if I call this my A and I call 7 my B, I literally just can go straight to this form. So this is going to equal, I'm putting 2 sets of parentheses here, and I'm writing 5x and 5x, and I'm writing a positive 7 and a negative 7.
Okay.
And all factoring really is, if I told you, if I said, hey, factor this number for me, or what are the factors of 14, what would you say?
I'd say like 7 and 2, 14 and 1.
Good. 7 and 2, 14 and 1. So let me just write 7 and 2. What does that mean about 7 times 2?
It means, well, what do you mean? It just means that 7 goes into 14 2 times.
But what does it mean? What does it mean about 2 times 7?
It means that they equal 14.
Yeah, 2 times 7 equals 14. So factoring, finding the factors of a number are basically just dividing it into 2 things that multiply together to make it.
Yeah.
Does that make sense? So watch what this does right here. All this means is when I multiply these together, and remember how I multiply things together, it would be first, outside, inside, last. I'd have to multiply all those, right? So I would have 5x times 5x, that's my first, plus the outside is 5x times negative 7. The inside is plus, the inside is 7 times 5x, plus the last is 7 times negative 7. And what happens when I do that? What do I get? I get 25x squared here. What happens to these 2 things right here?
They cancel out.
Yeah, they cancel out. And then I get negative 14. In other words, these 2 things multiply together to give me this. That is what factoring is. It's just like factoring 14.
But wouldn't the last one be negative 49?
Yes, it would be. So sorry. Thank you. I make silly mistakes all the time. So please correct me so that I don't keep them on YouTube. Thanks. Yeah, 7 times 7. 7 times negative 7 is negative 49. Thank you. All right. So do we have more factoring problems that I can do?
I think so, yeah.
Okay, let me jump to those since we're talking about it. And that way it'll just be a little bit more cohesive what we're doing. Let's see. This one is not a factoring problem.
I think wait, I don't know what slide this is.
There we go. Yep. This is going to be a factoring problem because it's asking you to solve this equation. And one of the reasons why you so I'm on page 5. One of the reasons why you factor is because it helps you solve equations. If you can factor it, it's easier to solve the equations. So it says, what are the solutions of this? Well, the way to find that is to first factor this equation out, or the left side. So notice that I can, first of all, I can take a 3 and an x out of each one of these terms. You good with that?
Yeah.
And what's that going to leave me here? Actually, yeah, it's going to 3 and an x. What's that going to leave me with right here?
That would leave me with x to the 4th power minus 6x to the 2nd plus 5
plus 5
yeah.
equals 0.
Yeah.
So the next step that I would want to do is try to figure out if I can keep factoring this even more. And I can because just like I showed you before, so I'm going to write the 3x out in front, but I'm going to make now, see how this is a trinomial. Now this is a 4 and a 2 instead of a 2 and a 1, which you normally see, but don't worry about that. All that means is I'm going to write x squared here and x squared here instead of x and x.
Okay.
Because remember, this is going to be your first. Your first always comes. This is always your first, and that's this times this. So just think about what I can break that into. And this is my last. Remember, my last is always here times here. This is always my last. So it's always here and here. So what can I, how can I break 5 up?
And for multiplication, so it can't be like 3 and 2, right? Because they would have to add.
Correct. Yep, it has to be multiplied. What are the factors, right? We're factoring. What are the factors of 5?
5 and 1.
Or how about -5 and -1?
Yeah.
And why do I know that I want it to be a -5 and a -1? Can you tell?
No.
Because this in the middle here is a -6x squared.
Okay, so if that was positive 6x squared, then I would just write 1 and 5 instead of -1. Okay.
That's right. And now let's just check it. We have to always check it, Matthew, to make sure it actually works. Let's check it to see if it works. When I multiply this times this, what do I get?
You get -1x squared.
And when I multiply this times this, what do I get?
-5x squared.
And what's -1x squared plus 5x squared? I'm sorry, what's -1x squared minus 5x squared?
-6x squared.
And that's what we wanted, right?
Oh, okay.
You see what I'm doing? We're just undoing, we're unmultiplying. In other words, we're dividing, or we are factoring. That's what we're doing. And what's x squared times x squared?
X to the 4th.
That's right. And what's -1 times -5?
5.
+5. And see, that's where do you understand what I'm saying? This is your first, this is your last, and this is your O plus I.
Okay, yeah, I understand.
You get that?
Yeah.
So here's my O, here's my inside, that's my I, that's my O, and this is my first, and this is my last. Okay, so that's how factoring works. Now, I just wrote that because I was checking it. The more you do this, the less you'll even need to worry about that. You'll just kind of see it, you'll write it, and then you'll just move on from it. So I'm not done yet, because remember, they wanted me to find the solutions for this. So now what I have to do is I have to use the zero product property. The zero product property says if A times B equals 0, then A equals 0 or B equals 0. Either one would make that true.
Okay.
And that's the reason that we factor it, because you see what I have here now? I have this times this times this equals 0. Which means, how can I make this whole thing equal 0? I can either make this equal 0, I can make this equal 0, or I can make this equal 0, because any of those things, what's 0 times whatever?
0.
It's 0. And I'll get my answer for 0. That's the zero product property. So what I'm going to do now is I'm going to write these 3 things. I'm going to say 3x equals 0, or x squared minus 1 equals 0, or x squared minus 5 equals 0. And I'm going to solve each one of those on their own in whatever way I know how to solve it. So this first one, obviously just x equals 0, right?
Yeah.
So there's one answer. This other one, x squared equals 1. And how do I solve that equation? X squared equals 1.
You find the square root of 1.
But don't forget, when you're finding the square root, there's really 2 square roots, right?
Yeah, so it's
There's a
plus or minus.
positive and a negative. So there's actually 2 answers there.
Yeah.
And same with this one. X squared equals 5. So X equals plus or minus the square root of 5.
How
So there's
come,
actually 5 answers.
how come on the second one, the answer is X equals plus or minus the square root of 5, and on the first one, it's just X equals plus or minus 1?
Because what is the square root of 1?
1. Okay.
That's why. That's why. And the square root of 5 isn't a pretty number, so I didn't simplify that at all.
Yeah, okay.
Okay, good. Let's see if we can find another one like that before I go into those other questions that you have. Okay, so these other questions that I see that you have are more about simplifying exponents, which we can do, but that's a different beast than this factoring and stuff. So here's another factoring one. I'm on page 8 now. So here's a factoring one. This is another one of those rules. Remember I said there's these special products or these special factoring rules? Yeah. This is another one, and here it is. Ready? It's a cubed minus b cubed equals, notice I'm setting up I'm setting a binomial and a trinomial. And here's what it is. It's the same sign, the opposite sign, and always positive sign. They call this the SOAP. They call this SOAP. A lot of people call this the SOAP trick or whatever. So you see how this sign you see how this sign here is a negative? So I use the same sign, I use the opposite sign, and then the last is always positive. So SOAP is what it spells out. Okay. Has your teacher taught you that yet or no?
No.
Okay, so that's a lot of times you'll hear people do that. And the things that I'm putting in here now, I'm putting A in here, I'm putting B in here, I'm putting A squared in here, B squared here, and A times B here. That's just the rule. If you multiply it out, you'll see, wow, that works out. Everything cancels out except the A squared, A cubed, and B cubed. So the question is, what's being cubed here? Can you see? Well, first of all, 1 is being cubed, right? And the second part, what's 27x cubed? You know x is being cubed, but what is 27?
9.
Nope, it's not 9 cubed. Let's do our cubes. Ready? Here's 1, 2, 3, 4, 5. 1 cubed is 1. 2 cubed is 2 times 2 times 2, 8. 3 cubed is 27. 4 cubed is 4 times 4 times 4, which is 64. 5 cubed is 5 times 5 times 5, which is 125. Those are my perfect cubes. Okay. So if this is x, this is x cubed. It's good to know those. So this is 3x cubed. So this equals, again, I'm going to do my SOAP thing. Same, opposite, always positive. So I have, and I notice what I'm doing. I'm putting my A. So A is 3x and B is 1. And I'm literally just plugging those in just like this says over here on the right. Yeah. So my A, it's going to go A, B, A squared, which is 9x squared, B squared, A times B. And that's going to be your answer.
So wouldn't, at the first of the, oh wait, how come you wrote 9x squared and not just 9x?
Because it's A squared.
Oh.
And so what's A again?
3. Or 3x.
It's 3x.
Okay.
So 3 squared is 9. So it's 9x squared. I could have written 3. I could have written 3x in parentheses squared. You could have done that. But then you'd want to simplify that more into 9x squared. Okay. You understand?
I do, yeah.
So 9x squared. And let's just check it to make sure it works. Okay, here we go. I'm going to check it. What's 3 times 9x 3x times 9x squared.
27x squared.
27x cubed,
Yeah.
right? What's 3x times 3x?
9x squared.
So that's positive 9x squared. Good. What's 3x times 1?
3x.
Good. What's negative 1 times 9x?
9x.
Squared. Sorry, 9x squared.
I just
Neg-
9x squared, yeah. Or negative 9x.
What's negative 1 times 3x?
Negative 3x.
And what's negative 1 times positive 1?
Negative 1.
Good. What happens to these things? Gone. And these things? Gone. What's left? 27x cubed minus 1.
Okay.
But see, that's not something you could do on your own in your head, like figure it out. You have to know the trick.
Yeah.
So for some of the factoring things, you just kind of have to know the trick. So there's a bunch of rules. I'm sure it's in your notes somewhere. And maybe it's not. You know what? Maybe you missed out on that because of COVID. Maybe you missed that whole piece of information, but they're out there. You can find them. And if your teacher does something like this as if you should know it, just raise your hand and be like, hey, I'm sorry, I don't know that I've ever learned this. Can you show me again what that is? And hopefully they'll be able to go over this with you like I just did. Okay.
Yeah. So you know which trick to use based off of the first exponent, right?
Yes, for those ones you do. Yes, correct. Those are called special products.
Okay.
Or special factoring in that case, special factoring. All right, so now I'm on page 3. Do you see page 3?
Yeah.
So now this is a totally different thing. This is simplifying exponents, or this is properties of exponents. That's what this is. So I'm going to show you how I would do this. There's a couple ways to do it, but I'm going to show you how I would do it. First of all, I would deal with the negative power on a fraction. And whenever you see a negative power in a fraction, I'm going to write this over here. If you see a over b to a negative power, just flip what's inside there.
Yeah.
And make it a positive power exponent. Okay. So that's the first thing I'm going to do. I'm going to write negative x to the 5th. I'm going to leave everything the same. I'm just going to show you one step at a time. Times, and now I'm going to just flip it. So x to the negative 3 y squared over y, and that's just to a positive 1 power. Okay. The next trick or property, they're not tricks, I want to show you is when you have a negative power, I like to just put a box around it. So a negative power, let's see, a to the negative x is the same as 1 over a to the positive x. In other words, when you have a negative power, it flips to the opposite side of the fraction bar and becomes a positive power.
Okay.
Okay. So I'm going to rewrite this. It's going to be negative x. Again, I'm not changing anything except that one thing, that one. And in fact, I don't need these parentheses anymore, right? So I've got a y squared that stays on the top, and I've got an x to the positive 3rd that goes to the bottom. Do you understand that?
Yeah.
And that's because that was that negative. So now I've taken care of all of my negative powers. Now I'm going to move on and deal with the numbers. Now you might say numbers. There are no numbers. There is one number here. That number is a negative 1.
Mm-hmm.
Right? And what is this does this negative stay or does it go?
It goes.
And how do you know? Does it go away or does it stay? Is there a negative that's going to stick around in this fraction, or is that going to turn into a positive and just go away?
I don't know.
So the trick here is if there's an odd number of negatives that are multiplied together, then the negative sticks around.
Yeah, okay.
If there's an even number, does that make sense? Because a negative times a negative is a positive.
Yeah.
But then if you add multiply another negative to it, that becomes a negative.
Mm-hmm.
So this is actually going to stay. This negative is actually going to stay. So,
yeah.
So what happens is I basically just have a negative x to the 5th. And now notice that negative isn't in the parentheses anymore. Okay. And then I have an x squared y to the 4th times. Oh, let me show you one other trick. I'm just going to put all of the things now that I've taken care of that. I'm going to put everything on the top and the bottom just as it is. Because it doesn't really matter that I have two separate, it doesn't matter that I have two fractions anymore, because everything in the top multiplies everything in the top, everything in the bottom multiplies everything in the bottom. And so I'm almost done. Now all I have to do is figure out how many X's are on the top and the bottom, and how many Y's are on the top and the bottom. And here's how I like to think of it. Now there's properties, there's properties I can tell you, but I would prefer that you think of it like this. What does X to the fifth really mean?
1 to the 5th.
Not 1 to the 5th. It means X times X times X times X times X, right? 5 times.
Mm-hmm.
You understand that? And so if I have X to the 5th, like up here, doesn't that just mean that I have 5 X's that are being multiplied together up here?
Mm-hmm.
And can't I cancel those with some of these down here?
Yeah, you can cancel it 5 times. That's
right. So all I really have to do is count the number of X's I have on the top and the bottom, and whichever one I have more of, that's where they stay. I cancel all of them out except the leftovers. But you can see I have 5 X's up here, and I have 2 plus 3. I have 5 more down here. So what's going to happen to all of the X's?
They cancel.
Yeah, all of the X's are going to cancel. And how about the Y's?
Those don't cancel.
Good. How many do I have in the top? How many Y's do I have in the top?
You have 2 on the top and then 5 on the bottom.
Very good. Good. And so in total, how many would cancel?
2.
2. And how many would there be left, and where?
There'd be 3 left on the bottom.
Perfect. Now what number is going to, so the Y to the third is on the bottom. Well, do I put there's nothing left on the top. So what do I put up there?
A 1. Or a
Not a
1.
positive 1.
Yeah, -1.
A -1. You understand why?
Yeah, because there's still the negative in the front of the.
That's right.
Yeah.
Perfect. Good job. All right. So that was good. That was a good problem. Let's try this one. So same kind of deal, right? I'm just going to simplify, just like I did the other one. I'm going to simplify. I'm going to simplify it and try to deal with this in the simplest way I possibly can. And I'm having a hard time moving it around. So give me a second here. What page is this? 5? Nope. What page is this? 4? 4. See if I can clean this up at all. I can't. Unfortunately, I can't clean that up because the image is too big. So I'll just do it right here. Okay. So the first thing I'm going to do is I'm going to flip these two and make that a positive. That makes sense?
Yeah.
And then I'm going to take this whole thing right here, and that's going to go down because of the negative. That whole thing is going to go to the bottom. That makes sense?
Yeah.
So in this first fraction, I have just a 1 left on the top, and I have X to the -2, Y to the 6th, and X to the 5th.
Okay.
And I'm not really done with that yet. By the way, there's more than one way to do this, but that's just the way I'm preferring to do it. I'm going to make that a 3 there, and I'm going to flip what's inside. X to the 4th, negative Y to the -4th. I didn't change anything on the inside of the parentheses. I just took the whole thing, and I basically got rid of these negative powers that were on the outside. Now I have to get rid of more negative powers. Remember the other trick I told you? Put a box around so you can see clearly what you're moving. Notice I'm not putting a box around that negative, because this negative number right here is not in the base of this exponent.
Okay.
Do you understand that? Because there's no parentheses around it.
Yeah.
So you really should think of that as a -1 sitting outside of that Y to the -4. So now I'm going to move all of those things back up. I'll just do this in black right here. So this is going to be X to the +2, and it's gone from down there. And this is going to be Y to the +4, and it's gone from down there, but there's still a -1 sitting around.
Yeah.
Okay. All right. So now my next step is let's just try to simplify some things. Can you see that I've got 2 X's here and 5 X's? Well, no, I'll just leave. No, well, crap. All right. Well, the first thing I'm going to do is take this 3 and I'm going to distribute it into here. And that rule is this: if you have a to the n raised to the m power, what do you do with the two exponents?
I'll
just tell you, you multiply them.
Yeah.
So I'm going to actually multiply these in here. I'm going to multiply this in here. So this is going to become this. I've got x squared on the top. I've got x to the 12th on the top because those multiply. And I got y to the 12th on the top. And on the bottom, I have a -1 cubed because that's also applying to that. And what's -1 times -1 times -1?
-1.
Good. So I still have a -1 on the bottom. I'll just put that in parentheses. And then I still have these two down here, y to the 6th and x to the 5th. Make sense how I got all that stuff?
Yeah, it does.
I'm just kind of cleaning stuff up. So let's do the same thing I did before. How many x's do, oh, what's the number first of all, positive or negative?
For, sorry,
this whole thing. For this whole thing, what's the, is it going to be a positive or a negative?
Negative.
It's going to be a negative because you have -1 down there. So just put a negative up there. How many x's do I have on the top?
14.
And how many on the bottom?
5.
And how many are left over?
9.
Good. Where?
On the top.
Perfect. 9 left on the top. How many y's do I have on the top?
12.
And how many on the bottom?
6.
So how many are left over?
6 on the top.
Perfect. Now, do I have anything left on the bottom?
You have a 1, -1.
But do I need to, well, and it's not a -1 because I put the -1 on the top.
Yeah, so just a 1.
So do I have to write that 1 in the bottom?
No, because
no, in the bottom you don't have to write it. On the top you would. So I'm just going to erase that and I'm just going to circle it and there's my answer.
Okay.
Make sense?
Yeah.
All right, man. Well, hey, that video is on my YouTube channel. You text me later or email me if you can't find it. Okay.
Okay. Thank you.